Hello everybody, welcome back to Bleepin' and Bloopin'. I wanted to do a short video about this patch using some of my favorite modules that you've seen me use in the past, my Joranalogue Select 2 and Compare 2. As you all know, these are some of my favorite modules. I like that I can patch program them into a lot of different things. I had a previous video about using them to do min and max. So this video is about rectification. Rectification is a pretty common thing that you do in electronic circuits, and basically you take a bipolar or an AC signal and you use different versions of rectification to convert it into a unipolar signal. So you start off with a sine wave, looks something like this. This is a very poorly drawn sine wave, but you get the idea. And so for a half wave rectifier, you basically just ignore anything that's negative. And so you end up with a signal that looks like this. If you were to do a full wave rectification, you take the negatives and you flip them into the positive. So you end up with a signal that looks like this. Now this has quite a few uses. Probably the most common one, not directly related to synthesis, is that it's used in AC to DC power conversion. So the power supply that's powering this rack right here probably has some form of rectification going on inside of it. As far as synthesis goes, this can be really useful and helpful in Eurorack. If you think about it, a lot of our modulation signals are bipolar. So you might have a slow LFO that goes plus or minus 5 volts. But then you have things like your VCAs that only respond to positive voltage. And so maybe you want to quick and easily convert your bipolar signal into a unipolar signal. Well, that's exactly what rectification does. Another thing is that by changing the shape of these waves and removing the negatives or inverting the negatives into the positive in the case of full wave rectifier, we can add harmonics to waves that are in the audio range. And so you can see I'm going to have a scope here on the left of the screen and a frequency analyzer on the right side of the screen, so we'll be able to see all of that happen. And then I already have it patched up here. First we'll start by walking through the patch. The really cool thing about using select and compare to be a rectifier is that we can go from half wave to full wave and never even need to move a patch cable just by adjusting the dials on the Select 2. We have a clean sine wave coming in from my Instro TSL that goes to the input of the Select 2. And then that is also jumped over using my stacker cable to the input of the Compare 2. And then the output from the Compare 2 goes to unity of the Select 2. So what's happening here? Well, I have Compare 2 set up with the knobs shift and size knobs to the max. And what this does is this tells us when the signal is positive. So anytime the signal is positive, we'll get a positive gate on the out. And then over here on the Select 2, we're relying on the interesting unity behavior. And so what unity does on the Select 2 is anytime a high gate is sent in there, it will switch to unity of the output and ignore this attenuator. And so what we're doing is with the attenuator to the max, that would be outputting unity already. So switching to unity would have no effect. So you can see here on the screen, we have the same wave. The red one is our sine wave from the TSL, and yellow is the output from Select 2. So really nothing's happening. But if I slide this over to 0, so that we are at full attenuation of our signal, get it just right there, then what's happening is anytime Compare 2 is detecting that the incoming signal is positive, we choose unity, and otherwise we choose 0. And so you can see we have a half wave rectified signal here. We only see the positives, and the zeros all just sit flat at 0. Now this is where the really cool flexibility of Select 2 comes into play, because if we want to take this half-wave rectifier and convert it to a full-wave rectifier, all we have to do is rotate our attenuverter into the negative. So what's happening here? Well, what's happening is the input signal is being inverted compared to is still looking at the original uninverted signal and showing us the positives. And whenever it detects the positive in the original signal, it will trigger unity on the select to. So we're switching back and forth between inverted and uninverted, depending on if the original signal is positive or not. And so this is actually the same patch that we would use to patch our select to as a ring modulator. Now we have our full wave rectified signal, and we can also roll it back to our half wave rectified signal, or we can go all the way and get the whole signal. And if we take a look at the spectrum analyzer, we can see very clearly this first chunk of the spectrum is our fundamental of the signal, and there's a little bit of noise down here and a little bit of noise on either side. But as we move to half wave rectification, you'll see the harmonics start to increase. And so we're adding some interesting harmonics to that sound. And as we pass half wave and go on into full wave, we'll actually see the fundamental start to go away, and the octave up will become the new fundamental of our new signal. So we can listen and hear what that sounds like. I'll go back. This is our clean, untouched signal. And we'll be able to hear the harmonics as we roll through rectification stages. All the way to the point that now we're listening to an octave up. So you can use a full wave rectifier to generate +1 octave if you want to. Of course, it adds other harmonics, so it's not a clean octave shift, but it does create some interesting sounds. All right, well, that's all I had for today. I hope you find this useful. I'm gonna be putting it to use in a video series, like I said, that I've been working on. I needed a half-wave rectifier for one of those videos, and rather than buy one, I decided to figure out how to patch one up. So stay tuned, keep an eye out for those videos. I think they're gonna be really interesting, and we'll see you in the next one. Thanks.